Hi folks, Mr. Long here. We're going to do a screencast today on derivatives of radicals and rational exponents. And what I want to do is go over first of all, what radicals and rational exponents are. So radicals are just what you see right here. A radical, if you look at that, a radical is just like a root sign. You can't really see that very well, can you? There. So a radical is a root sign, and a rational exponent is a fractional exponent. Rational, its root of that is ratio, means fractional exponents. So if I had x to the 4 over 3, and just as a reminder, a bit of review there, this means the root, the 3, and whoops, and again, you can't really see that. Let me bring that down to there. The 3 is the root, and I'm in the top right of the screen, and the 4 is the exponent. Okay, and going back and forth is what I'm going to do right now. So let's do some review then. So the first thing we want to do is some review, and we want to represent each of these with radicals. So we're starting with a rational exponent, a fractional exponent, and 10x to the 1/2. The 2 indicates the second root or the square root, and 1 is the exponent on x. So what it really is 10 square root of x to the exponent of 1. And I could put a little 2 right there, but usually we don't put that 2 there because it's the most standard root. And I don't have to put that 1 there either. So it's really just 10 root x. Okay, so 10x to the 1/2. If I go to the next example, x to the 4 over 3. X to the 4 over 3 indicates that it's the third root or the cube root raised to the exponent of 4. And I can write that 2 different ways. I could write it as the cube root of x in brackets to the 4th, but I can also do it as the cube root of x to the 4th. And I'll just move that up so it's easier to see. Okay, it's easier to see there. Okay, so you can see that in both of those cases. Right there, that represents the third root of x, all raised to the exponent of 4, or I can see it as the x to the 4th, the third root, or the third root of x to the 4th. These are equivalent representations of x to the 4/3. Okay, the last one. What if we have a negative exponent combined with these roots? Well, negative exponent means, again, repeated division. So that's going to have to appear in the denominator with a positive exponent. And let's take a look at what that would look like. So it's going to end up being 1 over 2, because that 2 is in the denominator, x to the 2 over 5. And then the 2 over 5 is an indication of being a fifth root and raised to the exponent of 2. So I can do that as 1 over 2, and it would become the fifth root of x squared. Okay, if that's a 5 there, the fifth root. And I will move that up so it's easier to see. Okay, and that's going from a rational exponent to what's called a radical. So anything with a square root symbol or a root symbol is a radical. With fractional exponents, it's a rational exponent. There are different ways of representing things. Your final answer always in my class needs to be in a fractional exponent. Okay, let's go to the next page and do a few more examples. So we're going to represent each of these as a rational exponent. So we're starting with a radical. So that 3 there indicates the cube root, which is to the 1/3. So I would write that as x to the exponent of 1/3. And then B, in example B, the exponent is 2. That's going to appear in the numerator. It's the fifth root. That will appear in the denominator. X to the 2/5. By the way, I'd encourage you to rewind it, stop it. You might want to look back. Again, make some notes. Go through. I would put these examples right into your notes so you have a nice set of notes. Okay, the next one. I have root x inside and then a 3 outside. That 3, I could write it this way as well. So it could be written as the square root of x cubed if I wanted. That 3 can appear outside the root or inside the root. You get equivalent results. And if I was to do that, again, the numerator in this case would be 3, and 2 is the root, so it appears in the denominator. Here's a trickier one because it's already in the denominator, so I'd write this as, oh, I think I skipped ahead here. Sorry about that, folks. There we go. So for this one here, 1 over the root of x would just be 1 over x to the 1/2. And then in turn, that would be x to the negative 1/2, written as a rational exponent, bringing the negative up to the top. Okay, subtracting 1 from fractions. I know this seems like, why would I be doing this? Well, you know, in the power rule, you always reduce the fraction or the exponent by 1. So the way I do this is I always look at that 1, and then I look at my denominator over here, and I represent it in the same denominator. So 1 over 2 minus 1 is 1 over 2 minus 2. 1 minus 2 is negative 1 over 2. So again, represent this number here with the same denominator as the other fraction. 5/3 minus 1 then becomes 5 over 3. Not sure why it's doing that. 5 over 3 minus 3 over 3, because 1 can also be 3 over 3. 5 minus 3, subtract the numerators, is 2. The denominator is 3. Okay, the next one, negative 3 over 4 minus 1. I need to represent that 1 with a denominator of 4. So it's going to be negative 3 over 4 minus 4 over 4. Negative 3 minus 4, negative 7 over 4. Okay, that's subtracting 1 from fractions. Okay, and we do that by representing the 1 with the denominator that's in the fraction. Okay, I think you'll get that fairly quickly. All right, let's differentiate. So we're going to do the derivative of root x. Now, the derivative of root x, the way we're going to do this is we're always going to write them with a rational exponent or a fractional exponent. So we rewrite f at x equals x to what exponent? 1 over 2. Now I apply my power rule. Okay, I haven't differentiated yet. Now I'm going to differentiate. So I write f prime of x. Bring that to the front. 1 over 2. And then it's x to the 1 over 2 minus 2 over 2. Okay, 1 over 2 minus 2 over 2. Why did I minus 2 over 2? Because it's 1/2 minus 1. And that's going to end up being 1 over 2 x to the negative 1 over 2. And in turn, x to the negative 1 over 2, 1 over, I bring that to the bottom, make the exponent positive. Okay. Negative 1 over 2 in the top becomes 1/2 in the bottom. Negative exponents, repeated division. And lastly, I need to convert that back to a radical. X to the 1/2 is root x. So it's 1 over 2 root x. So our rule is then, this is when you're going to want to commit to memory. The derivative of the square root of x is 1 over 2 root x. Okay, you do that derivative often enough that you should know that by memory. Okay, remember the d by dx means you haven't differentiated yet, but you're going to. Okay, so the derivative of root x is 1 over 2 root x. And the process is, you might want to write this down. 1, convert radicals to rational exponents. 2, apply the power rule. 3, simplify back into radicals. Okay, it's just like negative exponents. Okay, for this one here, I need to differentiate that, which looks fairly complex. If you remember from the negative exponents, I can take that 3 and I can move it outside. So that becomes 3 derivatives, d by dx, of, and it would be x to the 6 over 4, right? Because the 6 is